Okay, sorry, this went a few minutes long. So we should move on right away to Giuseppe Guarino of the University of Bologna on the impact of digital technologies on field survey. Is our approach to archaeological data collection and management effective? Thank you.
Okay, good afternoon, everyone. It's a pleasure to be here with you today. First, I'd like to thank Marco for inviting me to this workshop. About me, I'm pursuing a PhD in geophysics and remote sensing applied to archaeological landscapes. My research, titled Methods and Techniques for Archaeology Without Excavation, Case Studies and Applications, focuses on the use of non-invasive methodologies and techniques for investigating ancient urban contexts, specifically applied to the Roman city of Suasa and Valerio Picenus in the Marche region. The decision to concentrate my research on these two contexts is motivated by the common characteristics of being abandoned Roman cities. However, the case study I will present today concerns a part of the research conducted at the site of Suasa. Suasa represents an exceptional case for applying non-invasive survey techniques, such as aerial photography and geophysical surveys. The first geophysical surveys date back to 1989 with implementation of geoelectrical investigations that highlighted part of the forum area already identified through historical aerial photographs. Subsequently, in 2009, the research group led by Professor Enrico Giorgi in collaboration with Professor Federica Boschi conducted future investigations enriching the repertoire of diagnostic applications, particularly in terms of aerial photography and geophysics. The integration of non-intrusive surveys, aerial photography, and excavation campaigns has led to remarkable results over the year, enabling to discovering of the city's main buildings. However, the site still has a high archaeological potential that unfortunately has not been fully explored due to the inaccessibility of some private fields, which prevent stratigraphic excavations, especially in the city's southern sector. Therefore, this context, although not new to the studies, was deemed useful to revisit in this doctoral research, aiming to systematize all previous work and enhance it with new acquisitions, including the use of updated and extended remote sensing equipment when possible. For my doctoral research, I had the opportunity to conduct new investigations, both in previously explored areas and in new ones. 2 weeks ago, survey campaigns were carried out in collaboration with the European Research Infrastructure for Heritage Science and the National Research Council. This was possible thanks to a project proposal which was positively evaluated by international experts following a call promoted by the IRIS infrastructure and funded by the Italian Ministry of University and Research. The project, titled Urbes Revelantur, New Remote and Proximal Sensing Investigations in the Abandoned City of Suasa, involved the use of data acquisition techniques via drones, such as multispectral images, thermal data, and LiDAR. Among the objectives is the improvement of historical topographical research of the study context, The result will be useful to address open topographical questions and more generally for the historical and diachronic reconstruction of the evolutionary phenomena of the Roman city of Suasa and the surrounding rural landscape over the centuries. In this contribution, I will specifically focus on the intrasite surface surveys conducted in March 2023. This preliminary phase of the research is still under development to extend it to entire urban area. So, before introducing the main topic, I would like to provide a brief overview of the case of Suasa and its unresolved issues. Suasa, located on the right bank of the Cesano River along the Via Salaria Gallica, developed in the first half of the 3rd century before Christ in connection with the Byzantine colonization efforts following the Roman conquest of the Ager Gallicus in 284 before Christ. The city underwent several phases of institutional and urban development. During the 1st century before Christ, Suasa transitioned from a prefectura to a municipium. This necessitated the city to be equipped with infrastructures suitable for its administrative autonomy. The urban structuring of the settlement was completed between the late Republican and early imperial periods, with a strong emphasis on public buildings. During this period, the forum was constructed, which assumed its final shape only in the Tiberian era, along with probable thermal buildings, the theater, the amphitheater, and the table on the podium, which maybe Francesca Pindelli will discuss later. The excavation of the city have revealed the monumental part of Suasa and the colossal Domus dei Coieti, located centrally in the forum area. Lastly, in his work Città senza case, la domus come spazio pubblico nei municipi dell'Umbria, Simone Sisani considers Suasa as a case study and discusses the lack of distinct private spaces. The urban structure of Suasa is characterized by a strong commercial component and reflects a management of public space that integrated civil and commercial needs without a clear separation between private and public spaces. According to Sisani, the Domus dei Coieti, situated centrally in the forum area, is a significant example of elite residential architecture in Suasa, characterized by large rectangular halls that indicate the central importance of these spaces. Built in the mid-2nd century before Christ, following the Appium House plan, the Domus dei Coieti underwent significant renovation between the Augustan age and the 1st century, and it may have been used for public purposes, thus responding to the administrative and social needs of the surrounding territory. Therefore, the lack of private spaces seemed to be one of the unresolved issues, compounded by the recognition of the city's physical boundaries, suggested by the presence of necropolises whose exact limits are unknown. Given the impossibility of conducting excavations in some fields, surface surveys in direct relation to remote sensing evidence can contribute to a better definition of the urban aspects of the Roman city. To answer these questions, in addition to geophysical surveys and the interpretation of aerial photographs, the survey and study of artifacts provide useful information about the functional use of the city. Another question concerned the method of collecting materials. So in recent years, various research groups have developed various methods to document archaeological investigations. Among the most common practices is the use of mobile app that allows the creation of databases and exploit the GNSS positioning of the device. On a practical level, the application is used to map each artifact often associating a photo to facilitate its subsequent identification in the laboratory. The strategy is often not to take artifacts or to take only those that are considered diagnostic. What are the disadvantages, in my opinion? First, even though the data can be easily loaded into a GIS, managing hundreds of thousands of points can be challenging. This makes it difficult to correct any biases that arise during the collection and significantly complicates data processing. Secondly, the GNSS positioning accuracy of the smartphone is about 3 meters under optimal conditions. The problem arises in areas with poor satellite coverage, such as those covered by trees, orchards, or forests, where accuracy drops drastically. The result is that the point for placing the artifact might be incorrectly projected elsewhere. Another issue is related to artifact recognition in their photographic documentation. This subjective aspect can make it difficult to identify the artifact later, leading to false interpretation. Additionally, there is the issue of interoperability between the GIS software used to manage this data. The choice to not collect artifacts can be advantageous in terms of storage, but it requires thorough understanding of material archaeology by all survivors. And this is disadvantage as well we'll see in the case I am about to present you. Among the advantages compared to field grid mapping, the acquisition is significantly faster. The system is user-friendly, making it easy for operators to use. So I think there is no one strategy that is better than the other. Several factors can come into play in selecting the optimal strategy, including time, space, and available funds. The area where we conducted the first surveys is located to the north in a largely unexplored sector, despite being only a few hundred meters from the amphitheater. It was decided to conduct an intensive reconnaissance, adopting a more traditional approach involving the creation of a 10 per 10 meters grid over the study area. At the same time, a digital app was used to record the artifact finds on site, collecting at least at this stage only the diagnostic ones. Although we are aware of the problems involved. Some students participated in the survey. Then before the start of the survey, the students were brought together in the laboratory for a lesson on ceramic recognition. The process initially involved the creation of a grid on a Floss GIS platform, in this case, QGIS. Subsequently, the grid squares were plotted in the survey area using a differential GNSS system. The students explored each square following a zigzag path with a distance of 2 meters within each profile to improve the visibility of the findings. This approach was particularly useful during daylight hours when the sun, low on the horizon, could have hidden the finds in the shadows. To map the findings, we used QField. This application, although it presents itself with a very simple interface, is rich in functions such as tool for digitalization in the field, geometry and attribute editing, in the presence of the GNSS, the possibility of to upload custom base maps, the integration of a smartphone camera, and many other functions. QField can be considered a mobile extension for QGIS. It allows us to view and manage a GIS project created with QGIS on a smartphone or tablet. permitting the user to keep all set names, labels, and styles that are in the original project. So the grading on QGIS was created with a polygonal layer in which fields were inserted for compiling information on weather, visibility, and land use, and a column for each ceramic class to facilitate quantification. Also included were fields for photographic documentation, a field for storing the explorer's name, and several fields for written and spoken notes. Another field had the utility of coloring the recognized square by taking a button, allowing the work to be resumed from where it had been interrupted the previous day. At the end of each reconnaissance, the data was exported from each mobile device and synchronized in the main QGIS project. These are the aspects concerning the interface, which can be easily managed and customized. However, several issues arose during the survey. The most significant of these was that a preliminary laboratory examination of the collected ceramics, also documented in the field, indicated that the students' knowledge was insufficient to ensure reliable data at this early stage. The most common errors were the confusion between Italic and African sigillata pottery and the failure to identify Middle Adriatic sigillata. Overall, the survey documented the presence of a possible suburban villa that was probably active for the 1st century and no later than the 16th century. As is standard practice, specific analyses were carried out, such as kernel density estimation. It was decided to apply the analysis to bricks. The heat map visualizes the density of bricks collected in different areas of the archaeological site. Lighter colors represent areas with a higher density of collected bricks, while darker colors indicate areas with a lower density. The heat map and the box plot or violin plots provide a complementary view of the data. The heat map allows for the visualization of the spatial distribution of collected bricks, highlighting areas with high density, while the box plots or violin plots show the statistical distribution of the data, including median values and outliers. Together, these tools help identify and understand the concentration of artifacts in a specific area of the archaeological site. It can be observed 3 surveyors have similar distribution in this diagram in terms of brick collection, with most values falling within a narrow range from 0 to 20 bricks, and with similar medians. The 4th surveyor, however, has no data, as he or she did not document any bricks. Nevertheless, each surveyor has some outliers that indicate occasionally very high collection. The outliers show that on some occasion, the surveyors collected a very high number of bricks compared to the norm, suggesting a concentration of bricks in a specific area of the survey. Without falling into the trap of positivist scientists, the outliers can be explained in various ways. In addition to the more obvious higher concentration of bricks, it could also be due to counting errors in the field by the students. In this case, it will be necessary to create a weighted average that also considers the adjacent squares. The weighting process would have been more complex if each brick fragment had been documented. To conclude, I would like to address one last consideration regarding the integration of reconnaissance data with remote sensing data. This integration often presents various complexities. In the case of SWASA, ground penetrating radar conducted in surveys, conducted in cultivated fields characterized by seasonal ploughing, on one hand, facilitated the discovery also of surface artifacts, but on the other hand, they disrupt the archaeological stratigraphy, negatively impacting the interpretation of radar profile. As you can see in the images obtained from GPR surveys, plough furrows are visible in the time flight, and radar profiles have with a depth of about 60 centimeters, just here. Furthermore, the predominantly clay soil has further attenuated the radar signal beyond the depth, rendering the profiles unreadable. So far, the best results from GPR surveys has been obtained in areas untouched by modern agricultural machinery. On the other hand, a useful comparison for cultivated soils can be made using aerial photographs. During the first year of research, I observed a good correlation between the presence of archaeological traces and the cultivation, in particular of alfalfa. This plant creates roots that penetrate deep up to about 9 meters, which can positively influence the visibility of crop marks in aerial images. So the method used has pros and cons. The decision not to collect all materials affected the final results, and it is difficult to quantify any interpretative errors made in the fields. I did not want to address issues such as the standardization of a method, because I believe that each method must be chosen according to the needs of the research. So what definitely needs to be standardized is the use of a common vocabulary, and especially the use of interoperable and easily searchable software and databases. So, thank you.